Um, 70 question number 1. Prove that n square minus n is an even number for all value of n. So n square minus n is an even number we want to show for all values of n. So let's check like n equal 1. So 1 square minus 1 is 0. Yes, 0 we categorize as a even number. N equal to 2 square minus 2. 4 minus 2 is 2. N equal 3. 3 square minus 3. 9 minus 3, 6. N equal 5. 5 square minus 5. 25 minus 5, 20. Yes, it's working. This is true. But because of these examples, you can't tell this is not a proof. You can use the basic knowledge for this proof. One basic knowledge we have with the numbers, if you multiply by odd number by even number, then it is a even number. 2 times 3, the same as even times odd also. This is same, even. So those are the basics. One axioms or two axioms we can use for this proof. Now, if I have this one in this form, I can't do anything. That's all I can see, and uh, we don't know that. For example, if n is even, then n square uh, even no, or do you know this one? And then assume n square is even when n is even, then what do you know about n square minus n? So we can't tell anything. We can see that this answer is right, but there is no such a thing in around maths that. So what we could do, if we can write this one in a different form. No, I can see I can factorize this one. Now, how about this argument? This is a multiplication of two numbers. N is a number, n minus 1 is a number. So this is multiplication of two numbers. Okay, what do you know about this? If this, okay, case 1. If n is even, then n minus 1 is odd. Then n times n minus 1 is n is even, right? Even times odd is even. Already we know with the axioms. I mean the non-basics. Case 2. If n is odd, then n minus 1 is even. If n is odd, 5. 5 minus 1 is what? Even, which is 4. N is 7, then 7 minus 1 is 6, odd. Then n times n minus 1 is what? If n is odd times even, even. Then there is no other option left. Case 1, either number can be odd, even, we discuss the even part. Then the case 2, the number can be odd, then we discuss that part. Then there is no other part to discuss. Hence, n square minus n is odd? No. Hence, n times n minus is, even. N times n minus is, hence n square minus n is even? No. N times n minus is even. Hence, what is this one? N square minus n is even. You can't straight write like from here to here because we discuss on this one. So you have to stay with this one. N times n minus is even, hence n square minus n is even. Question number 2. When you look at this question, it's a proof. So we want to show that this one. When you look at this one, what you can see? So the denominator is vanish. So this is a root as well. Do you know a technique to vanish denominator? Have you learned anything something like this in the A levels? Yes. We did a subject called rationalizing. So we can use that knowledge. And we are going left to right or right to left. So usually it is easy to go in a simplification way. It's difficult to go in this way, expanding. So I take left hand side. What is left hand side? X over 1 plus square root 2. Then I multiply by both sides 1 minus square root 2. So answer is x over 1 minus square root 2. This is 1 square minus square root 2 is here. Difference of 2 square. X times 1 minus square root 2 minus square root 2. Sorry. 1 minus 2. 1 minus 2 is plus 1, minus 1. I'll explain this one again. Okay. Now explain this one. X times square root 2 times minus 1. So I want to switch this one. So I want to multiply by, or I have to switch this minus bring to up. So it means minus x plus square root 2x. So 2 square root 2x minus x. From here you can bring this minus 1 up. Minus x 1 minus square root 2. This is minus x plus square root 2x. So we'll switch the square root 2x minus x. Question number 3. So we want to show this one. Will I start with left hand side? X plus square root y times x minus square root y. Then you can write x times x minus square root y. So this is x, then other one is plus y. When you look at here, actually this is plus x and this is plus x. So we multiply by plus x and then we multiply by plus y. X minus square root y. So this is going to be x square. This is x square root y. This is yx. This is actually square root y. Square root yx. Then this is going to be y. Now x square minus x square root y. I can write this is x square root y minus y. So this is cancelled out and remain is x square plus minus y, which is right hand side. And this is question number 4. We want to show that this one. So we'll start with left hand side and we'll simplify this one first. Keep 2x minus 1 here. This is going to be plus x times x minus 5, then plus 6 times x minus 5. So 2x minus 1 equal x square minus yx plus, I'm explaining this one. This is plus 6x, 6 minus 6x plus times plus. This is going to be minus 30. So 2x minus 1 equal x square plus x minus 30 equal 0. Then 2x times x square plus x minus 30 and minus 1 times x square plus x minus 30. So this is going to be 2x cubed 2x square minus 60x minus x square minus x plus 30. So this is going to be 2x cubed 2x square minus x square plus x square minus 60 this one minus 61x plus 30. So equal RHS. Whatever you answer equal RHS. That's number 4. Question number 5, we'll take this is LHS x square plus bx, then x square plus bx. We'll add b square over 4 for b over 2 square minus b over 2 square. So this will become x plus b over 2 x square minus b over 2 square.